In this video, I want to introduce you guys to a little bit about probability theory and how we can compute it, and so that we can get started using it in many of our applications that we're going to be working on. So, what we're going to talk about in this course, we're going to introduce probability just to make sure that everyone's on the same page regarding things like notation and how do you actually compute it. And then we're going to quickly move on to conditional probability, and thus on to Bayes' theorem. So Bayes' theorem depends on having knowledge of conditional probability, and we're going to have lots of examples with all of this information as well. And then finally, we're going to culminate in knowing, we're going to be learning about the naive Bayes classifier, and we're going to use it, apply it to a data set of flights to see if we can predict if our flight is going to arrive late based on any number of given factor. So things like the distance between the two airports, what our departure time is, maybe the airline that we're flying. Given all this information, we're going to try to see if we can build a naive Bayes classifier that can predict if our flight is going to arrive late. So it's a really cool application of all the probability that we're going to be learning, but we have to actually get started learning some of this probability. So I just want to start off just introducing some concepts and probabilities and some notation as well, just so that everyone is on the same page. So probability is the likelihood of some event happening. So I have two examples here. I have one involving a fair coin, one involving a six-sided dice. So if you think about a fair coin has two sides, and so there's an equal chance or equal probability of a coin landing on heads or landing on tails if you flip it. And so here's just an example of some notation that we might use. So we say that the probability that the coin lands on heads is going to be equal to 0.5 or 1/2. And here's some notation that you might encounter in other places if you see it. So sometimes probability is denoted as a lowercase p, and then the event is going to be in parentheses. Sometimes it'll, especially with coins, sometimes it's just shortened to H or T. Sometimes it'll be capital P, sometimes we'll have the full word prob for probability, but this is just some notation. You might see this in many places. There's no standardized way of this notation. And speaking of events, so an event is just some kind of action that has a probabilistic outcome, such as flipping a coin is an event, because we don't know what the outcome is yet until we flip the coin. And for chance of a coin, it's 1/2 on each. Now, again, a dice toss is another example of an event. There is a 1 in 6 chance of it landing on any one particular number. So if you roll a fair dice and it lands on 3, the probability that it landed on that 3 is 1 out of 6. But we can do some more advanced. We can do a bit more of an advanced problem. So we can ask, what's the likelihood that this dice lands on an even number? Well, how many even numbers are there on a six-sided dice, right? There's 2, 4, and 6. And how many different sides are there on a dice? There's 6. So 3 divided by 6, 1/2 is equal to 0.5. So in general, here's how we compute probability of some event E is quite simply just the number of ways that E can happen divided by the number of total possible outcomes of our event. So in the case of our coin toss, the probability of heads, there's only one way that it could happen, is that it lands on heads. The number of possible outcomes is 2, because there's a heads and a tails. It could have landed on heads or tails. So just some precursor, just some information, just get everyone on the same page. Speaking of probability values, all probabilities go from 0 to 1, including 0 and 1. So if you have something with a probability of 0, then we're saying that this event is impossible. If you have something with a probability of 1, we say that this event is certain, and then somewhere in the middle, an even chance is 50%. So it's important to know that probabilities only range from 0 to 1. It doesn't make sense for anything to have a probability greater than 1 or less than 0. Okay, so one other concept that I want to just discuss is this notion of a complement of an event. So the complement of an event, and here are all the different ways that you can write it. Again, there's no standard notation for this. You might end up seeing all of these. The complement of an event is all of the outcomes that are not in that particular event. So let's do an example to get a better picture of what's going on. So suppose I want to compute the probability that a roll of the dice is not 1. So what are the different outcomes where the dice would not be 1? Well, it turns out there are 5, right? The dice could be 2, 3, 4, 5, or 6. So they're 5 out of 6, and so we end up with 5/6. So that's just kind of the complement of this, what it means for an event to have a complement. And if we can compute it in another way, we just take the complement is equal to 1 minus the actual event. So here's an alternate way of computing this. I can say what's the probability that the dice is not equal to 1 is equivalent to saying what's the probability of 1 minus the dice actually being 1. And you can see that mathematically they equate to the same thing. But this is just an alternate way to compute a complement. So really, given any kind of a probability, we can immediately compute what's the probability of this not happening just by taking 1 minus that number. All right, so let's do just one more example to get this in your head. So suppose I want to compute the probability that a roll of a dice is strictly greater than 4. Well, how many outcomes is that? Strictly greater than 4 doesn't include 4. So the only two possible outcomes are 5 and 6. So that's 2 divided by how many outcomes are 6? 2 divided by 6, and I should just reduce that to 1/3. Now I can say I can take the complement of that event, and if you use the formula, you can actually immediately compute it as being 2/3, because 1 minus 1/3 is 2/3. So here's just some notation of the probability that a dice is strictly greater than 4 is equal to, if I say, what are the different outcomes of a dice not being strictly greater than 4? Well, that means that the dice roll would have to be less than 4, including 4. And it turns out, again, these are equivalent things here. So, what is the likelihood that the dice lands on a number that's less than 4 inclusive? Well, that's going to be 1, 2, 3, 4. 4 out of 6 possible outcomes, that's going to be 2/3. So, and again, there's another way to compute this. If you have something like a dice, or if you have a coin, or some other kind of classic probability thing, classic probability objects, classic probabilistic objects, if you want to think of it that way, you can try to take the whole complement of an event and tie that into the actual geometry of the object itself, like what I've done here. Alternatively, if I had something else, I would have to do the 1 minus trick to compute this out. But notice that all the numbers add up, all the math that adds up, right? So the probability that a dice is strictly greater than 4 is going to be 1 minus the probability that the dice is not strictly greater than 4. So it's just going to be 1 minus 1/3, and so that would give me 2/3. And again, all of this adds up. So this hopefully is just this is really just to keep everyone on the same page when it comes to probability in terms of notation and how we actually compute probability. So hopefully this is just kind of giving you, is kind of quick, but it's just giving you an idea of what probability is and how we're going to be using it in the future.